Awesome. So, hello everyone. My name is Vitaly, and I'm robotics nerd. I'm really into robotics since I was a kid, and for the past 10 years, I've been working with robots, with everything from drones, rovers, autonomous boats, industrial arms, and the quadruped robots as well. Yeah, and today I'm going to talk about open source developments in robotics because there is actually a big ecosystem of open source robotics tools. I will start by talking a little bit about the history of open source in robotics and explain what tools exist. And then I'm going to offer my perspective and propositions as a Web3 community, what we can add to robotics community. So I want to start by saying that it's prime time for robotics right now. The market for service robotics has grown 48% last year. And new market verticals are just flourishing. A lot of new projects are starting. Obviously, AI innovations unlock a lot of new possibilities in robotics. We started with industrial drones, robots like 30 years ago. But more recently, we start seeing robots that navigate our complex world with convolutional neural networks before. And now with transformer models, we see companies training more than 100 tasks each day. So the opportunities to implement robotics in new, never before possible use cases is now, essentially. And I want to ask you, how many of you have heard of ROS, Robot Operating System? Awesome, some did, but not that many. So ROS is the dominant open source frameworks for robotics developers. It has around 150 active developers last year, and a few million people has worked with ROS over the years. And it has packages for most, and the tools for most things that robotics developer may need for navigating and for planning a path of control for industrial arms. Gazebo is a great simulation tool that would allow you to try things out before you actually deploy it on the physical hardware. So ROS is like iOS and Android combined, and a lot of other tools as well in robotics. So every single roboticist I know, at least at some point, have touched ROS. Some people don't like it, some do, but nobody would deny that it is a dominant framework in robotics. And it was started in essentially out of research first, but then quickly got into incubation space called Willow Garage, where all the early innovations in service robotics happened. A lot of startups that were successful in robotics over the past 10 years has started in Willow Garage, and Robot Operating System was developed there as well. And initially, it was more of a researchy project. It was not thought of as something ready for enterprise adoption, for example. But then around 2018, enterprise companies have started to look into ROS more. AWS released the Robo Maker, which allowed to run simulations of ROS on their cloud for any scale. And around that time, we saw much more adoption. And in 2022, Google, through their company Intrinsic, has bought a significant portion of ROS. 2/3 of developers are now working closely with Google. And just a few weeks ago, a new structure was announced, Open Source Robotics Alliance, that would be continuing to maintain open source ROS. So now is the actually a perfect time to get involved with ROS community because it's changing a lot and it requires more contributors and more participation from the community. And so, yeah, as I said, some of the biggest robotics startups came from Willow Garage and were acquired, have some of the largest fleets. But I think now we're at the stage where new AI models can create more than $100 billion innovations in robotics industry. And my assumption is that ROS2 specifically would probably be at the foundational layer of that value creation. So yeah, ROS is a great framework, but what can we do as a community to help them grow, and what learning we have in our ecosystem that we can offer roboticists? There is also one important shift that is happening right now. There is a transition from ROS version 1 to ROS version 2, and it's going for a few years already because it's oftentimes difficult projects in robotics, so teams take time to migrate to a new system. But still, more than half of the developers already use ROS 2. And among many things, it includes the robot security, it adds real-time control, which is very important for more practical use cases. But what I wanted to talk today is the modular communication stack that exists in ROS 2 that didn't exist before, which means basically that we can change the whole communication stack that exists within ROS to anything else. And I think that existing alternatives that we have now in ROS community are mostly focused for smaller fleet operations. So primarily, it's focused on one company operating their fleet, setting up private networks, and just only having authorized connection to the robots. I think that communication stack of Web3 projects can unlock global accessibility for robotics with the same level of protection as if they're running on private networks, essentially. My team has been actively contributing to ROS community for a while now. As a part of Robonomics team, we have given a grant to write Rust implementation of ROS so that ROS can be run on more low-powered hardware, low-efficiency hardware. The team at Merklebot has developed an agent that is currently running on the robot, and that allows to set up communication over P2P between all the other agents and our platform as well. And we already uploaded more than 10 terabytes of data to Filecoin network because we believe that Web3 tools are very applicable to robotics, where operations are usually geographically distributed as well, and having a data storage location close to where operations happens makes a ton of sense. P2P already built in. We just added support for that. Yeah, I think I may need to. And the idea is that I'm now running a version of the agent on my laptop, and there is a version of the agent running on the robot. And no matter what the configuration of the network will be, whether we're in the same local network or we use different protocols, we can still continue have stable communication, hopefully. The message was sent now through P2P, so I have the agent running locally on my machine, and the device is running the version of the agent as well. And we can set up any kind of control for the robot. And right now, the agent that we're running enables communication between my device and the robot itself. It also aggregates all the data that is captured by the device, all the videos and all the logs from the machine, and encrypts it with a key of that is stored in my agent on the laptop as well, so that all the data as it goes back and forth, no matter what configuration of the network will be, whether we have a server in some remote location and a fleet of drones flying around it, completely offline with no internet, or we have a setup where like this node is connected to the internet and then uploads information to the cloud. All of those scenarios are possible, essentially. And so right now, this is just early demo of how P2P could be used for robotics deployments, but we think that there is an opportunity to be much deeper into ROS and have that as an alternative to existing DDS solutions that exist in ROS. And that is not a replacement for what exists today, I have to say. I have to stress that it is an alternative that has its unique use cases. So primarily, it's global accessibility of the robot. Whenever you bring your new robot to some location which is remote, you don't have to set up private network. You don't have to do any new setup for it. As long as it's connected somehow to the internet, it can get discovered by any node anywhere in the world. And also, there is absolutely no setup that is required for heterogeneous devices. So it could be a drone, it could be a rover, it could be any type of device, and they could talk to each other as well. And plus, by using P2P, for example, we do get access to additional tools that are built by the community as well. So we do use IPFS, for example, for protecting the data as it moves through the communication stack that we offer. And some other Web3 tools that Eventually, we want to create a fully working robotics economy where authentication can happen through the public key cryptography that's used in blockchain networks. Storage networks, obviously, can be used in decentralized way. Even financing of robotics and payment to robots directly for services could be set up through decentralized infrastructure of blockchain networks as well. So I think by making this first step towards implementing communication stack, we can unlock opportunities to implement more Web3 tools in robotics in general in the future. So yeah, thank you so much.